4. Which of the following would not be a likely outcome after a forest near a lake is converted to a farmland? So what would not be a likely outcome when we have forest near a lake converted to farmland? The water becomes cloudy. The health of animals living near the lake is negatively impacted. Dissolved oxygen increases from 1 milligram per liter to 5 milligrams per liter. The number of fish species in the lake reduces from 5 to 2, or a non-native fish becomes the dominant species. Now, this is looking at this, making an assumption that this farmland is going to have a negative impact, that the farming methods are being used, include use of fertilizers, and there's some runoff. But given that assumption that there is a negative impact on a forest by the nearby farmland, let's see what would happen. So often, fertilizers are used that contain nitrogen and phosphorus, and the result can be eutrophication, as nitrogen and phosphorus are added to a lake, and that limiting factor for the primary producers is then removed, because now they have enough nitrogen and phosphorus, or at least they have more. One result of eutrophication is that the water becomes cloudy. And this increase in turbidity is due to increased algae and phytoplankton in the body of water. So what would not be a likely outcome? Water becomes cloudy. That is a likely outcome of eutrophication. Really, the topic here is eutrophication. B, the health of animals living near the lake is negatively impacted. This is likely if eutrophication occurs, because the toxic algae in the lake during an algal bloom can make their way up the food chain as the consumers and then the secondary consumers and the tertiary consumers end up ingesting this toxic algae directly or indirectly. So this is a likely outcome. Dissolved oxygen increases. So is the dissolved oxygen going to increase in eutrophication? No. No. So this is not a likely outcome because the dissolved oxygen typically goes down. And the reason that the dissolved oxygen goes down, I'm not sure if I highlighted this before, so I want to now, is that the decomposers in eutrophication, decomposers increase because now there's all this detritus by the increased biomass from phytoplankton and zooplankton and algae and all this. So the decomposers increase from consuming the detritus, and they consume oxygen. So decomposers increase as they consume the detritus. And the decomposers then in turn consume oxygen, so there will be decreased oxygen concentration in this lake, not increased. The number of fish species in the lake reduces from 5 to 2. This is likely. This dissolved oxygen reduction is going to reduce the number of fish species that can live in the lake. So this is likely. A non-native fish becomes the dominant species. This is possible because the native species might not be able to survive these new reduced oxygen conditions, and then an invasive species can take over. It's an invasive species that might be tolerant to reduced oxygen. So you can see that the impact of nitrogen and phosphorus being added to the lake can be vast as eutrophication occurs, and it changes the whole balance of the community within the lake. So the only thing I would not expect is for dissolved oxygen to increase. That concludes the section on ecology here at Educator.com. Thank you for visiting.